Good morning everyone. Now I am going to discuss a problem on angle between the two normals of the surfaces. Okay, in this two cases are there. One case is if the two surfaces and one point. In the second case only one surfaces, 2 points. In the first case, two surfaces at a point means we can find out the normal to the first surface, that is n1 vector, the normal to the second surface, that is n2 vector. In the second case, we can find out the normal to the surface at a one point is n1 vector, at another point is n2 vector. If we can find out the two normal vectors to the surface along the point or the surface at 2 points, in two cases we can find out two normals, and we know that the angle between the two vectors means n1 vector dot n2 vector by modulus of n1 vector modulus of n2 vector is equal to cos theta. By using of that relation, we can find out the angle between the normals to the surface at 2 points or angle between the surfaces at a single point. Okay. Now I am taking one problem. I am taking two problems in two different cases, and how we can find out the angle between the normal to the surface at 2 points, angle between the normals to the surfaces at a single point. Okay. The problem is, find the angle between the surfaces. Find the angle between the surfaces x square plus y square plus z square equal to 9 and z equal to x square plus y square minus 3 at the point 2 minus 1 2. Second one is find the angle between the normals to the surfaces. Find the angle between the normals to the surface x square equal to yz at the point points 1 1 1 and 2 4 1. Solution. In the first problem, they have given two surfaces at a single point. In the second problem, they have given only one surface with the 2 points. In two cases, we can find out the normals to the surfaces. The first problem solution is, let the given surfaces be F1 is, let it be F surface. F is represented as x square plus y square plus z square minus 9, and G is represented as x square plus y square minus z minus 3 at the point 2 minus 1 2. Okay, we know that the normal to the surface, we know that the normal to the surface phi at point P is n vector is equal to del pi at P point. This is the relation of the surface at point P normal vector. Okay. If we know the relation of normal vector to the surface at a point, then we can simply to find out the normal vectors to the two surfaces. Okay. Here let it be n1 vector is equal to del f at point 2 minus 1 2 and n2 vector is del g at point 2 minus 1 2, and let theta be the angle between n1 vector and n2 vector, that is nothing but angle between the two surfaces. Then cos theta equal to n1 vector dot n2 vector by modulus of n1 vector modulus of n2 vector. This is the formula of angle between the two normals. Now we can find out partial derivatives of f surface. F surface is x square plus y square plus z square minus 9. Find out dou f by dou x. This f surface is differentiating with respect to x. Then x square derivative is 2x. The remaining terms will be 0. In the same way, dou f by dou y is equal to 2y. The remaining are 0. Dou f by dou z is equal to 2z. And n1 vector equal to, or del f is equal to I dou f by dou x plus j dou f by dou y plus k dou f by dou z. Then del f is equal to 2xi plus 2yj plus 2zk at minus 2 minus 1 2 at point 2 minus 1 2. Then normal vector be n1 vector is equal to del f at point 2 minus 1 2. Therefore n1 vector equal to 4i minus 2j plus 4k. This is the n1 vector. In the same case, g is represented as x square plus y square minus z minus 3. Find out the partial derivatives. Dou g by dou x, that is equal to 2x. Dou g by dou y, that is 2y. Dou g by dou z, z differentiative is minus 1. Then del g is equal to I dou g by dou x plus j dou g by dou y, that is 2xi plus 2yj minus k. At 2 minus 1 2 point n2 vector is equal to del g at 2 minus 1 2. That is n2 vector is equal to, substituting the point 2 to the 4i minus 2j, it is constant, minus k. This is the n2 vector. And find out the angle in between of two surfaces at a point 2 minus 1 2. Therefore, cos theta is equal to n1 vector dot n2 vector by modulus of n1 vector modulus of n2 vector. That is equal to n1 vector is 4i minus 2j plus 4k dot 4i minus 2j minus k by under root of 4 4s are 16 plus minus 2 whole square plus 4 whole square, that is 16, under root of 4 4s are 16 minus 2 whole square plus 4 minus 1 whole square plus 1. It is equal to dot product in between of the two vectors, that is 4 dot 4 is 16 minus into minus plus 2 to the 4 4 minus 1, that is minus 4 by this is the 36 root 36 into root 21. Therefore, plus 4 minus 4 get cancelled. Therefore, cos theta is equal to 16 by root 36 means 6 root 21. 2 3s are 2 8s are, it is equal to 8 by 3 root 21. Therefore, the angle between the surfaces is, from this, theta is equal to cos inverse of 8 by 3 root 21. This is cos inverse 8 by 3 root 21. It is the solution of given problem. Okay. Next we can find out the angle between the surface at 2 points. The given surface is, second solution, the given surface B pi is equal to x square minus yz, and the points P equal to 1 1 1, Q equal to 2 4 1. In the second case, the surface B, one surface, let it be pi surface, that is a pi scalar, and the points, 2 points, let it be P and Q. Okay. Next, we know that the normal to the surface pi is n vector equal to del pi. At 2 points, we are getting the 2 normals. Okay. Now we can find out partial derivatives of pi scalar. Del pi equal to I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. Since pi is equal to x square minus yz, that pi scalar is differentiating with respect to x, then in this only x term is x square, then x square derivative is 2x. Dou pi by dou y means first term has no y variable. In the second term y derivative is 1. The remaining term is, that is, minus z. Dou pi by dou z means in the first no z variable, in the second y treating as a constant, then z variable derivative is 1. Look, we can substitute these values in the del pi. Therefore, del pi is equal to 2xi minus zj minus yk. It is the del pi. Next, let n1 vector is equal to del pi at point P, n2 vector is equal to del pi at point Q. Therefore, n1 vector is equal to, at point P means P is equal to 1, 1, 1. n1 vector equal to del pi 2 into 1i minus 1j minus 1k, that is equal to 2i minus j minus k. And at q equal to 2, 4, 1, then n2 vector is equal to del pi at q means 2 into x value is 2 minus z value is 1 minus y value is 4. It is equal to 4i minus j minus 4k. And let theta be the angle between two normal vectors n1 bar and n2 bar is cos theta equal to n1 bar dot n2 bar by modulus of n1 bar modulus of n2 bar, that is equal to, the first n1 vector is 2i minus j minus k dot product in between of two vectors. The second vector is 4i minus j minus 4k under root of 2 square is 4 minus 1 square is 1 minus 1 square is 1 under root of 4 square is 16 minus 1 square is 1 minus 4 square is 16. It is equal to dot product in between of two vectors, 2 4s are 8, minus into minus plus 1 minus into minus plus 4 by root 6 root 33. 16 plus 1 17, 17 plus 16, that is 33. 33. It is equal to 8 plus 1 9, that is 13 by under root of, in this root 6 can be written as root 2 into 3, root 33 can be written as root 11 into 3. From this 3 common, 3 root 22. 11 to the 22, or simply 33 is multiplied with 6, 6 3s are 18, 198. Therefore, cos theta is equal to 13 by under root of 198. Then theta equal to cos inverse of 13 by root 198. It is the Therefore, the angle between two normals is cos inverse of 13 by root 198. It is the solution of given problem. Okay. This is the procedure how we can find out the angle between the two normals. Okay. Thank you. If you like this video, please subscribe my channel and share your friends.